Good evening, My name is Mauricio Moya, and I will be presenting the case A2 for National City Bank, where I will be showing. I will be developing a customer propensity model for a new product offline of credit against a household use card. So the structure of this assignment is to show the case introduction, description and process, exploratory data analysis, the methods used, the top 100 households, actionable insights, and conclusions. Let's start with the case. Well, I'm presenting this case as member of the research modeling team for National City Bank, and I'm honored to have been given the opportunity to present this work in this examining project. The goal of the team is to create a propensity model to a line of credit against a household use card and to identify 100 households to contact based on their probability of accepting the loan offer. In this presentation, I will be providing an overview of the process that our team followed to develop the propensity model, and I will be also be sharing the insights that we gained from this analysis. Regarding the structure of the data, we had 6 data frames as source, some internal, some external. They were calls, surveys, marketing campaigns, loyalty programs, and estimations. And third party were purchasing behavior statistics, demographics, and public information available. The other data frames were the axiom, which is the self-evident details of the user, the credit behavior of worthiness, and vehicle details of the card of the household. We had 29 variables all in all, 5,000 clients in the database, and about 130,000 records. About the description of the data, we had 40% overall. Well, the majority of data in both prospective and current customers were numeric, about 40%. Also, there were significant number of character type, around 40-50%, while the logical and factor type were around 6 to 11%. In the records of the discrete versus continuous plot, in regards to the discrete versus continuous plot, for the prospective customer, the discrete column had a higher percentage, around 50%, compared to the continuous column, as we can see. In regards of the missing data, we had a prospective customers with higher percentage of missing data, 10%, but that's mostly used due to the Y column missing. While current customers only had 3.7, indicating that the data quality may be a concern for a prospective customer dataset, and it's something that maybe the bank should take in account for later to control better the way they gather the data. As we can see, that's statistics in charts. We already talked about it. And if we split the missing data along the different type of data, we see that 100% of the data missing is factor, and the one that has also a high percentage of missing data is the logical type of variable. Now we can see the uniqueness of data split by plots. We can see that the origin data frame, like current and prospective data frames, they had more than 60%, well, 50 to 60% of the source data, and then 20% came from the credit data. After that, we can see the vehicle data, and at the end, the action data. Unique data is most important for data ID, HH unique ID, obviously, but besides the unique IDs, we had also the recent balance as one of the most important variables, the annual donations, the day passed, previous attempts as well. And we can see later that if we look at the unique data in terms of why, no, this is not unique data. This is the analysis of the behavior of the acceptance by different groupings that I made. So right now is I'm presenting the way I thought of creating new variables. And one of those was the time of the call. So I split it by 4 groups the first time and then by 5 groups. And we noticed that most of the acceptance is below 15 minutes. And if we split it in different time sets like 2, 5, 10, 30, and 60 minutes, the biggest groups accepting the here. The biggest groups accepting the offer for the loan are between 5 to 30 minutes. Then regarding the EDA, wait, I'm sorry. This is all the variables that I constructed manually. The age generation, like Boomer, Boomer 2, Gen Z, Gen X, Millennials, post-war, the age of the car, the age category. As we can see, the categories were based on how old the car was in a all new or average way, and the car decades. After that, the EDA, we noticed that the data is split in 40% acceptance and 6% rejection. Now, for the interesting variables, we can see that, for instance, here in the top, the last month of contact, September, March, and December were the ones where the users accepted the most. And the past outcome, if they get a loan before, they also will probably get a new one. Here we also see that the students buy more. In the next, we can see like the time group that I told you before. The post-war and boomers are those most interested in buying new cars as well. Regarding the EDA by age, we can see that most of our users are between Gen Z and, well, millennial, Gen X. Yeah, millennials are Gen X, and that's the distribution of data along all the variables of this case. Regarding the methods that we use 3 methods: the logistic regression, the random forest, and the decision tree. These are the results of the method we use. In the top left, we can see the probabilities of rejection or acceptance. The top 10 variables, as we can see, are communication, past outcome, marital status, but that's one that was treated with D-treat. The number of contacts prior this call, the pets purchases, job estimated raise, but mostly people, it was from Alaska. Previous attempts, days passed since the last call, and annual donation. Then on the bottom left, we can see that the acceptance rate is 71% against 29% for the training data, which is current customers, marketing campaign. And the acceptance count was 540 in total. 150 were accepted and 382 rejected. In terms of the evaluation, the score was 0.01 for accuracy. All in all, the F1 score was 78 with the rest of the KPIs that we use. And in here, we can see that the ROC curve tells us that this model is not really good at differentiating the true false from the real. I mean, it could be better. This is right now 0.69, and I'm correct. 0.71, it's not as bad. Then for the random forest, we also got a 0.78, but a very bad ROC, 0.5, a precision 65, recall sensitivity of 1. Most of the variables were similar to the one in the logistics model. The decision tree shows us the accuracy was very high, around 0.72, one of the highest. And the rock curve had a similar behavior as in the random forest. All models had a 0.78 F1 score, so it was hard to decide, but I went for the logistic regression model. So in terms of the top 100 prospects, what I did was to, let's go to the document here, this one, this one. So here, once the model was decided, we used the best fit. In this case was the logistic regression. So we just are going to run this one here. There you go. Now we'll go back to the bottom and we can see that when we test the data, and get the outcome, the output we basically treat the test based on the plan, and then the output has also the best fit. We get the top 100 results. We unify it with the IDs. We cut it by the 50 by the 0.5 because we need to see which one are going to be rejected and accepted. Then we have the top 100 results in the Y. We create the Y, we fill it up with what they will do. Then we order the data in a certain way. We get the top 100 results, and also here we can see that I generate a new column wheel to see visually. Data is not generating right now, but it was doing. Basically, the outcome, as we can see in the here. So basically, this is the outcome document, which has the IDs, the probability of success, which will be having an acceptance, and the response in binary and also in text. As we can see, everything above 0.5 will be accepted, and that's 100 results. The interpretation of these results basically tell us that that those are the clients that we're gonna go first to ensure that the company, in this case the bank, is gonna make calls and get the clients to accept this loan in the highest chance. In this matter, the company will be able to reduce the costs and increase their revenue by assuring they will contact customers that will actually take the loan. Some insights in this case. Let's go back to the data we saw. I wanted to point something here very important. Is that data, the quality of data must be controlled for all the companies in order to get better predictions. If we have too many missing data, the models are not going to be efficient, even if we run them through B-treat or any other statistical methods that will clean the empty data. Then we also need to consider the source, that it has a good quality, that is wide and long, and covers much of the behavior that could explain the decision of the user or customer. And also, it's very important to generate variables that will allow us to understand better the behavior, either for age or any other um, a characteristic of that. All in all, the conclusions are that in this case, all the models had this overall the same performance, and it was a tough decision to choose one, but we went for the logistic. Another conclusion is that using these methods will allow the bank to reduce their costs and increase their revenues. And yeah, basically making sure business should implement these models in order to have a higher success. Thank you so much.